going to be doing today is computing the value of an annuity. Now, just to recall, an annuity is a specified number of fixed payments received over a period of time. So what we do with this is that we're basically taking the value of multiple present values. Okay, so we know our basic time value of money formula, which is telling us that our present value, the value today, is going to be equal to the value of that future payment, that cash flow received in the future, and that is going to be divided by 1 plus our discount rate, however defined. Okay? And then this is raised to the t power. So that t is showing us how long it's going to take until we actually receive this. Okay? So, but when we look at an annuity, is that we have a multitude of these different payments. Okay? So let's say we're looking at an annuity where we have time period 1 plus time period 2 plus, and then we have a whole bunch of intermediate, and it goes up to, say, 10 years. Okay? So if in this example here, if we were making a $1,000 payment, okay, plus then we have a $1,000 payment coming in year 2, we have it coming in year 3, 4, 5, 6, 7, 8, 9, 10, all the way up until this year 10, where we receive that $1,000 payment. Okay? So what we do is that we take all these values and we bring them back to a value today, right? So we have all these 10 payments, they are discounted, and then we look at what the actual value of this annuity is. Okay? Now, we're going to do this with this. A basic example is we're receiving 3 payments of $400 at a 10% discount rate. Okay? Now, what we do is we're still taking our basic time value of money formula here. We have our value divided by 1 plus r to the t power. But the one change that we have here, right, when we use our fixed payments, is that we add up these payments. We use that summation, right? So we have starting at t equals 1 and through n payments. Now here, what is n? N is equal to 3. That's the number of payments that we're going to receive. So we have n is equal to 3, right? We have r is equal to 0.1, right? Because our discount rate here is at 10% rate. And then our v is going to be $400, right? So what we're seeing here is that we have $400 payments received in year 1, year 2, and year 3, and we are discounting that back at 10%. Okay? Now, as we do this, we are going to set up this according to our cash flow, right? So we're going to set up in year 0, year 1, year 2, year 3, and year 4. Okay? Time period 0 is when? It's right now. It's today. Okay? So what am I going to be receiving here? We're going to be receiving 0, right? Because we have our first payment coming at year 1, right? This time period right here. So we have a $400 payment coming, okay, in year 1. We also have a $400 payment coming in year 2. And we also have a $400 payment coming in year 3. What's coming in year 4? 0. Why 0? Because we only have 3 payments. And those payments are coming in year 1, year 2, and year 3. Okay? We have a 0 payment in year 4. Okay? And then we're going to add up all the value of these and bring them back to our current value today. In order to do that, this isn't telling us our present value is $1,200. Okay? This is telling us it's going to be a value less than that. Right? Because these payments coming in the future are worth less to us right now. So when we discount all this here, this is going to be over the top of the 1 plus 0.1, okay, raised to the first power, right? Because we are raising it to the first in that first year. Year 2, it's going to be that 1.1, 1 plus our discount rate of 10%, raised to the second power, okay, because we are coming in year 2. We then come out to year 3, and we have the 1.1 to the third power, right? Raised to the third power because we're in the third year. We come out here to year 4, and we have this still 1.1 and raised to which power? The fourth power. Now this question is, why did I write this up here? The reason being because, you know, even though we have the 0 payment, is that we can still discount that. It's still going to work out to 0 no matter which way we slice it, right? So we don't really have to look at those of 4, 5, 6, 7, 8, 9, 10 years, right? We're just focused on these years 1, 2, and 3. Okay? So what we want to look at here is how do we compute our PV? Okay? Simply, we can plug all this stuff in our calculator the longhand way, you know, take the 1.1, raise it to the third power, and then put it down, right? But we have a much easier way. And that easier way is actually going to be using our calculator. The thing we're going to do is we're going to clear our calculator. We're going to hit that second and then clear TVN button. Okay? And now when we're doing this is that we're going to put into our calculator all these things, and it's going to tell us what the value of these payments are right now. Right? So we're going to take this 3, and that's going to be our number of years. So we're going to hit that N button. Okay? And then we have our I over Y, which is this button right here, which is our interest rate. And so we're going to put this in as our 10. Okay? So that's going to have an interest rate of 10%, as you see right here. The next thing we put in is we put in our present value, this button right here. But that's what we're solving for, right? So we're going to skip over to this next payment button. This payment button is the one where we have the repetitive payments. Okay? So this is our annuity button. So we have our $400 payments. We hit our payment button, right? So we had the 3 payments that we put in for N at 10% and $400. Now, in our future value, we have a 0 future value, as we have discussed, because basically there's not a lump sum coming at the end. Okay? So when we do this, the next button we hit is going to be the compute, this button right up here. So we hit compute, and then we hit our present value button, and it tells us we have a present value. This annuity is worth to us $994.74. Make sense? All right, awesome. Thank you for watching this lecture. Have a nice day.